Okay, so here is the rules for branched alkanes. What we're doing now are branched alkanes. So the first rule says, if there's one substituent, give the lowest number possible to that substituent. You already know this rule. Let's look at this for this first compound here. So we have here, you can think, what is the parent? First, you have to identify the parent chain. That will be the longest chain. What's the longest chain here? Here we have 1, 2, 3, 4, 5, if we go like that. Or we can go up, and we would also have 1, 2, 3, 4, 5. So either of these, either that or this is the longest chain, but they're the same thing, so we just pick the straight one. Now, how do we number this straight carbon chain in order to give the lowest possible number to this substituent? Obviously, we want to go in this direction, so we're going to go like this. 1, 2, 3, 4, 5. Okay? And now we're going to give the parent chain a name. The parent chain has 5 carbons, so we call it pentane. And why were we giving these numbers? Because the numbers are going to give an address for this child here, this methyl group. Okay, so here we have a methyl. This thing is a methyl because it has just one carbon. One carbon equals methyl. So it's going to be, we're going to write methyl, but we have to give the methyl an address. What's the address of the methyl? Carbon number 2. So we have 2 methyl pentane, and there's no space here. There's no space. Let me get rid of that space. So it's all one word here, 2-methyl pentane. And the only thing you notice is that, of course, whenever you have numbers and letters, the numbers must be separated from the letters by a hyphen. So that hyphen there always separates numbers and letters. So here's our final name for this compound. Let's look at another one. First of all, let's erase some of this stuff here. And let's look now at another one. So here, this one looks different from this one because here I put all of the hydrogens sticking out. Okay, so you can either draw it like this with all the hydrogens sticking out, or you can draw it like this with the hydrogens kind of squeezed together. So here, like this CH3, you could have drawn it as CH3. That's C with 3 H's. Okay, but most of the time it's easier to just draw it like this. Anyways, let's look at this one. What is our longest chain here? So let's see. We have here 1, 2, 3, 4, 5, 6, 7. Okay, that looks pretty long. If we go up, then we go 4, 5, 6. Okay, so that's not long enough. So we want to go this way. 5, 6, 7. And which way should we count? Should we count the way we just counted? Or should we count the other way? 1, 2, 3, 4, 5, 6. Oh, it looks like whichever way we count, we're going to give this guy here the smallest address. His address is always going to be 4. So it doesn't matter which way you count. Alright, so let's leave it as the first one, the blue one there. Okay, and we get our pen back. So now that we've counted, we have 7 carbons. So that must, of course, be hep for 7, heptane. And then this guy here, this substituent, has 2 carbons. And it has 2 carbons, remember? It's meth eth prop. Okay, here's a nice mnemonic for meth eth prop. Monkeys eat peeled bananas. Monkeys eat peeled bananas. Oops, I didn't spell bananas correctly. So monkey is M, that's meth. Eat is E, that's ethane. Peeled is P, that's propane. And B is bananas, that's bute or butane. Okay, so monkeys eat peeled bananas. That's a nice mnemonic you can use there to remember that. All right, so here we have not meth, but right, did I say meth? Here we have eth. Okay, since we have 2 carbons. So this is going to be a 4, 4, and we always separate the numbers from the letters with the hyphen. And then ethyl, heptane. And of course, there's no space. So let's bring that closer to indicate that there's no space. Nice, 4-ethylheptane. That's the end. Actually, let me make sure that I'm doing these right by checking here on my answer key. Yes, so far so good. All right, let's move on to the next one. Here is another rule. So if you have, it says multiple substituents of the same kind, then what are we going to do? We're going to use numbers for their positions, and we're going to use di, tri, and tetra to count them. Let's see what they mean by that. What do they mean by that? So here, first we identify the parents chain. That would be 1, 2, 3, 4. Or we can go the other way, 1, 2, 3, 4. And this other way is better because it'll give these guys an address of 2, which is lower than 3. So we want to give them an address of 2. So let's go back and we stick with the second one. 1, 2, 3, 4. Perfect. Now that we have done that, we see that there are 2 substituents, 2 children. The children are both methyls because they both have just 1 carbon. So we have a methyl here and we have another methyl here. What does it say? It says when you have multiple substituents, use di, tri, and tetra to count them. Di is for 2, tri is for 3, and tetra is for 4. So here we have 2 methyls, so it's going to be dimethyl. Dimethyl. And then we have, of course, the parent chain, which is 4 carbons. That is what? Butane. So we have dimethylbutane, but we need to give the address of these dimethyls. They're both located at carbon 2 of the parent. So we do 2, 2, and then as always we separate the numbers from the letters with the hyphen. Okay, so because there are 2 different methyls, we need 2 addresses, 2 and 2. 2, 2, and then we put the hyphen to separate the numbers from the letters. Let's look at this next one. So first we identify the longest chain. Let's see. Let's try maybe that one. So we have 1, 2, 3, 4, 5, 6. Okay, but is there a longer one? I think so. If we go 4, 5, 6, 7. Ooh, so this one is longer. So that's actually the parent chain there. So let's use that one. But which direction should we number it? Let's see. So we're using this one. Well, let's highlight it so it's a bit neater. So we're using this one as the parent chain. Now what direction should we use? Should we go like this? 1, 2, 3, 4, 5, 6, 7. Or should we go the other direction? 1, 2, 3, 4, 5, 6, 7. Which one will give the lowest number? So if we go in the red direction, then we have a 3 here. So this guy will have an address of 3. If we go in the blue direction, then the lowest address would be a 4. So we want to go in the red direction. So the first one we did was correct. So we go this red way, and we have here an address of 3. So first of all, let's name the parent chain. So the parent chain has 7 carbons, so we can call it a heptane. Okay, and now let's look at these substituents. So we have here on carbon number 3, we have here a substituent with two carbons, okay, which makes it an ethyl. So we have an ethyl there. And here we also have a substituent with 2 carbons, which also makes that an ethyl. Now what are the addresses of the ethyls? 3 and 4. So if we have 2 ethyls, what does it say up here? It says use di, tri, and tetra to count them. So that's going to be diethyl. So we have diethyl heptane. And we need to give the addresses. The addresses are 3, 4. So 3, 4, and then hyphen diethyl heptane. Perfect. Let's move on to another one. It says, now if you have multiple substituents of different kinds, so maybe you have a methyl and an ethyl and a propyl, you do the same thing we did before. You use the numbers for their positions and the di, tri, and tetra to count them. And finally, you arrange them in alphabetical order. So let's look at that. Let's look at this one. Zoom in a bit. So here we have, first let's figure out what our parent chain is. If we go this way, we end up with 1, 2, 3, 4, 5, 6. And I think that's the shortest. We could, sorry, that's the longest, I mean. We could also go 1, 2, 3, 4, 5, 6. But it's the same thing. So let's just use this one since it's a straight. Okay, so we use the straight one there. And then we can call that a, since it has 6, we can call it a hexane. Sorry, hexane. But what numbers should we give to these carbons? So if we go this way, 1, 2, 3, then that one will get a 3. But if we go the other direction, then this one gets a 2. So that's the way we should go. 1, 2, 3, 4, 5, 6. So this guy gets a 2, and what is his name, this guy? He is a methyl. That's a methyl. And that guy over there has 2 carbons, so that is an ethyl. Oops, what happened to my pen? That's an ethyl. Okay, so how do we do it now? So overall we're going to have, let's write it up here. We're going to have a 2-methyl, and we're going to have a 4-ethyl. 4-ethyl. How do we arrange the 2-methyl and the 4-ethyl? All we need to notice is that E comes before M on the alphabet. Okay, so it says when you have multiple substituents of different kinds here, you want to arrange them in alphabetical order. So E comes before M, so we're going to put the 4-ethyl before the 2-methyl. So let's try that. So we're going to have, I think maybe I need a bit more space here. Let's move that guy over. We're going to have a 4-ethyl. 4-ethyl. And remember, always you separate the letters from the numbers. So we put a hyphen there before we put the 2-methyl. The letters should never touch the numbers. It's always separated by a hyphen. So that's our final name there. 4-ethyl 2-methyl hexane. Let me check my answer key and make sure that I didn't make a mistake. Okay, that looks correct. All right, let's look now at the next one. And I think this might be the last one. Let's erase some of this. All right. Zoom out. Oh, this one looks tricky. Yosh. All right, so here, what is going to be our longest chain? So we can go in this direction, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or maybe we go up. So after we go 4, 5, 6, 7, 8. Okay, no, so we should go straight to give us 9 carbons. And how, in what order should we number them? Should we go like this, 1, 2, 3, or should we go the other way? It probably looks like we should go the other way, because then we can give these guys very low numbers. So here we go, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now we can give these guys a number of 2, which is perfect. First of all, let's name them. So here we have a methyl and another methyl. So this whole thing here, we're going to have a dimethyl. Let's just call that a dimethyl over there. Then over here we have something with 2 carbons, which is what? An ethyl. Ethyl. And here we have a child with 3 carbons, which is a propyl. Propyl. Okay, and what are going to be the addresses? The addresses of this dimethyls are both 2. So we have 2, comma, 2, and then hyphen dimethyl. The address of this guy is 4. So we have 4 hyphen ethyl. The address of this propyl is 5, so we have 5 hyphen propyl. And now we need to put them in alphabetical order. What is the alphabetical order here? So you might be tempted to say D is the first, because D comes before E, right? A, B, C, D, E. But we don't consider the di, the tri, and the tetra when we're putting them in alphabetical order. We only consider the first letter of the real child. So the meth, the eth, and the prop. So that means that eth is going to come first, meth will be second, and prop will be last in alphabetical order. So our final name then will be, we start with the eth. So we say 4-ethyl. We put a hyphen, and we go with the meth then. So 2, 2 dimethyl. And finally, we have the prop. That's 5-propyl. 5-propyl. And then we have the rest of it. Here we have 9 carbons, it seems, which is nonane. Nonane. Okay, that was a difficult one. Probably you won't get one that difficult on the exam. Let me make sure that I got it right. 4-ethyl 2,2-dimethyl 5-propyl nonane. Perfect. Okay, here's our last one now for the alkanes. It says, if 2 substituents are at equivalent positions, give the lowest number to the substituent that comes first alphabetically. What does that mean? So here we have a parent chain. That's obviously going to be this one. And we could name it in this direction. So we could have 1, 2, 3, 4, 5, 6, 7. Or we could go in the other direction. So we could go 1, 2, 3, 4, 5, 6, 7. Now, which way should we go? We're not sure, because in either case, we're going to have some child that will have 3. So here we would have a child that has an address of 3. And if we go with the green direction, we also have a child with an address of 3. So what direction should we go? It says that if two substituents are competing like this, we should give the lowest number to the one that comes first alphabetically. So first, let's name them alphabetically. So this one is what? Is a methyl. Methyl. And this one over here is a ethyl, or it's an ethyl. So which one comes first alphabetically? The ethyl. So the ethyl wins. So we're going to need to give the lowest number to the ethyl. So we need to go in this red direction. So we pick the red over the green. So if we pick the red over the green, then this guy is going to be what? 3 ethyl. You can forget about these greens. And that guy would, of course, be 5 methyl. 5 methyl. Could put 5 there. And what is the whole chain? The whole chain has 7 carbons. That will make it a heptane. Put a heptane there. And so we put it all together. We need to arrange it in alphabetical order as always. The ethyls will come before the methyls because E comes before M. So we say 3 ethyl, 5 methyl, heptane. Okay? And I think that is as difficult as they will ask you for the alkanes. In the next video, we will look at the alkenes. But of course, you need to do some practice with these ones. So I wish you luck on that. Bye-bye.